That's great. I've just been talking to myself for the last little while. That's good. Sorry, Trevor, as I was saying, which I had the microphone turned off, so of course you didn't hear me. The notes we were using were for 3, 4, and 5, the same notes we use across 3 presentations or 3 lectures. So I've just renamed it on the system now as presentation lectures 3, 4, and 5. To have, you see that, apologies, I'd said all that and then of course realized that the microphone turned off. It's just one of those days. No problem, Mike. We're just getting going. So that's that bit sorted. The one we're using tonight is, hi Louise. We're going to start looking tonight at chemical risks. And I know some of you already work with chemicals and involved in chemical safety, so I expect plenty of input from you guys who are the experts. Tell me what you do. And what we're doing tonight, we'll do it tonight and next week. So we'll have 2 weeks of this. So we'll do half of them tonight and half the balance of it next week. So the source of this document is there listed as a link on the front page. So we're going to get started. What we're going to cover in this week and next week is just looking at things like basic risks or risks, the chemical risk assessment, and just some evaluations at the end. This came from a chemical safety and training organization. So in this particular part of the process, which feeds into, I suppose, the overall concepts, we're looking at understanding the definition of risk, which we've done. So it'll be handy with a revision there. Definition between hazard and risk, or difference between hazard and a risk, since this is hazard analysis or hazard management. Understanding the factors that influence risk and risk perception. And it's always amazing that people's perception changes the more they do something, which makes it harder then to manage risk, or harder to manage the hazard, because some people don't see the difficulties. When you're working so closely with something day in, day out, you start to relax some of the practices, or it can happen. Or if you're in a hurry someday, you ease off the practices. We inverted commas forget, close inverted commas, the safety features, the safety regulations, to go all the way back and get the safety goggles or the ear defenders. I'm sure I'm only running across there for a minute. It won't be a problem. And then you find that's the one time something happens. So there's a few things we'll be looking at through this. Also looking at the safety risks associated with chemical facilities, which is a fairly specific area. Some of you, as I say, may have experience with this, so please feel free to throw your tuppence worth in to contribute to the process. As I say, we'll be aiming to do about half these slides tonight. We'll finish them next week. So we're looking at a hazard versus a risk. A risk can be an activity, which is then our perception of it. The picture of the guy here flying through the air on a BMX bike, not holding onto the handlebars. He has all the safety gear on, but there's still a risk. But the perception maybe isn't that it's as bad as this. He's done all the safety things he can do. He's still willing to do it. Somebody said to me once, you don't need a parachute to jump out of an aircraft. You need a parachute if you want to jump out of an aircraft a second time. It took me a while to work that one out. It was a slow day for me. It took me a while to work that one out. But it does make sense. A strange kind of sense. What do we categorize as a risk? What do we think of as a risk? We've looked at measuring risks in the past, and it's the one thing we've kind of said over the last number of weeks is that risks are subjective. it's our perception of what the risk actually, what a risk actually is, to an extent. Your risk, your safety reports, the risk analysis reports are written by somebody who's conducted some sort of an audit, and they've looked at what can go wrong. They've scored it, they've graded it, and people will give it different grades. They will see certain things as being more dangerous than other things. They will see somebody using sharp knives or sharp implements as more dangerous than somebody lighting a fire. Or they'll see somebody using a power tool more dangerous than somebody driving a car or riding a motorbike. It depends on perception. There's a lot to do with perception and what people's views are in relation to where something is being done, how it's being done. And even at that, it still comes down to our views as people. It's human nature, I think. The more we do something, the more blasé we become about it, the more relaxed we become with it, the more comfortable we become with it. And we can sometimes forget the risks. We can sometimes forget that things can still go wrong. At the same time, it becomes it can become a bit of you're the doomsday merchant. Mike, go ahead.
There is also, I mean, within risk, there's also a degree of learned behaviour, which is something I've gone into quite a lot. And the way it was described to me when I started looking into it was, how often do you drive somewhere that you do on a daily or very, very, very often, and you get there and think, Christ, how did I get here? You haven't remembered any left turn, any indicator, any roundabout, any stop. You've just driven there because it's learned behaviour. And so risk actually can diminish through learned behaviour.
Yeah. You go into autopilot.
Yeah.
Well, thanks for that, Mike. Yeah, you go into autopilot when you're driving. I mean, it's a question I would ask people when they're in various situations. I'd ask them, how did they get, if we were in the college, how did they get to the college? Or the last time you went somewhere, went to work or came home from work, exactly what you said, Mike. How many left turns did you make? What was the color of the last car that was in front of you and behind you? That was on the road before you arrived at your destination. We don't know. We're just an autopilot. We're just driving. We rely on the ability to react to something if and when something happens, but otherwise we're just, we're in a form of autopilot to just do it. Yeah, almost environmental hypnosis. Yeah, I like that phrase actually. Actually, it happened to me last Thursday. I was going to the college on Thursday afternoon, and in Carlow, I came up by the Pembroke Dental on Granby Road, and I was driving out towards the college, and about four vehicles in front of me, a works vehicle stopped because he was turning into a house or doing some renovations. He was hauling a trailer with scaffolding or something on it, and so he stopped, and everything stopped behind. But it's not a place we normally expect traffic to stop. So all of a sudden, I had alarms going off in my car about imminent collisions, which didn't happen. I wasn't going that fast in the traffic, so we were able to stop. But the two cars behind me, the car immediately behind me did stop just about, and the car behind him smacked him. I heard a bang. I thought initially it was the scaffolding just rattling in the trailer, but it's when I was driving away, the car that was immediately behind me did a sharp turn towards the curb, and as he turned towards the curb, the car behind him had the front of his car broken in. Where people don't expect a hold up once you come through the lights. It's all going to be clear run to Kilkenny or past the college anyway, or till we get to the roundabout down by the college, or the pedestrian crossing at the college. You don't expect traffic just to stop in the middle of the road because somebody wants to go legally indicate turn right, they were turning right and wanted to cross the road, and it kind of throws everything out of sync. So you're both right. I mean, this we just switch off to things, and it's a case of then how fast can our reactions reprocess the situation. And if we can't reprocess it fast enough, we end up with an incident. I won't call it an accident because it's lack of response time, which we have created through our comfort in the process. So our perception of the risk is that this is all going to be fine. We're after coming through the traffic lights. Now I can see the lights down at the college are all green, or just before the college are green, so it's all go. Next slow down place is the roundabout by Munnelly's garage. And after that, then it's a straight run up to the school. And once I get past the school, the Tyndall College, it's a dead straight run to the motorway. So we kind of relax a bit even more. It's interesting situation. It happens. The same thing happens in a work environment. You're driving a forklift. You're driving, the equipment around the warehouse, and it's fine. And we have no problem. I mean, I used to remember doing it all the time, which I shouldn't have, but did. Climbing around using the forklift like a climbing frame. You want to get something on the rack, so you put the forks in a certain way so that you could step up onto the side of the forklift and use just a step across to the forks, and that would raise you up a little bit. Now, if you do the next bit and get what you need and come back down again. If I had a load of rope or string, I would have tied it around the levers and I'd have used it and the frame to get me to hoist myself up even higher if I wanted to. Thankfully, I didn't have access to string and I didn't buy it. Yeah, it does happen now. We kind of ignore the risks once we get comfortable in the process. As as both Mike and Alan have said, it's this blindness, almost this myopia to the actual the risks that are around us, the dangers that can happen, and that's when things go wrong. That's when something happens. I mean, the people who are involved in most things like road traffic accidents don't go set out to have a road traffic accident. The people who had to crash behind me on Thursday, thankfully they didn't hit my car, but still I've been in that situation where a car in front of me braked suddenly on the M50. We were all traveling in bumper to bumper traffic. I braked, but there was all loose stones on the ground, so my car just ran along the marbles and tapped into the back of the car in front of me. It's not a nice feeling. You think you're doing everything right and everything's safe, and I suppose you could call it nature, fate, such situations, circumstances have a way of showing you how you don't really have as much control of the situation as you thought you did. And yet, we do break the rules. The difference between a hazard and a risk is, yeah, exactly. Off we go. A hazard is something that has potential to do harm. There's a lovely electrical arrangement here in the picture. Nothing wrong with that. That's all fine. Sure, it's only a couple of plugs. How bad could it be? If we weren't to do it, they wouldn't make those multi attachment sockets. We have more than one little hazard in that picture. You've got overloading of the system, of the actual was it supposed to be a 4-gang or something? Serious overloading of that. Each section is not individually switched, so I don't even see a sign for a fuse on it. Might be on the far side, but I don't see one anywhere there. So you've got overloading, you have potential shorts, you have different power types in there. So many things can go wrong. None of it is good. Overheating, whatever. The level of risk in anything will depend on a given situation. And technically all risks and all hazards can turn out to be fatal. And I think that's the view people need, or I suppose as health and safety professionals, that's the view we will have, that all all of these hazards or risks can actually be extremely dangerous and it can result in injury or fatality. But then that then sees health and safety professionals as the Grim Reaper. You're only looking for problems. As I've known from people who are in that field, who've told me that that's what they've been nicknamed in their organization when they walk into a room. The Grim Reaper is here looking for trouble. But that's what we're looking for here. We're looking for the things that people have become blasé about, have lost the alertness, who have not remembered what they've actually done, who don't remember did they hit the right safety switches or did they wire things correctly, that it just throw a few cables together and hope for the best. Because they do it all the time, so they weren't paying attention. They were talking to somebody, or they're just not paying attention. Just going through the motions. Sure, I do it all the time. I always put the red cable in the blue socket. You're supposed to put the red cable in the red socket. Oh, are we? When did that happen? Always. Oh, that would explain why it didn't work then. Unfortunately, it's natural, and this is what our job is. It's to get out there and deal with it. The hazard is they could have an overloaded circuit. The risk assessment of the thing is the possible scenarios that can happen. So we're looking at blown fuse, injuries to the worker, fire, likelihood of it happening, and the factors that lead to that, your various work habits that people have. And you go to any site, go to any situation, you'll find a socket like this, or go to any office, you'll find a plug like this around the place. You'll find a plug that's running multiple systems off it, and different types of systems. Because people haven't been made aware of what are the dangers, or if there are dangers. You don't have anybody analyzing them, checking them. We don't have an understanding, perhaps, of the consequences of what we're doing, or how we're doing something. I'm often fascinated watching things like talking to people in the role as well. You know, people like pilots and the checklists that they have to go through, the checks they have to do before the aircraft moves, while the plane is being loaded. You know, the flight crew up front, and all the stuff that they have to do is crazy. It seems crazy, you know, especially on a short haul flight where they've flown the plane, literally just landed the plane, and if it's not that long more, they're the last person to sit in the cockpit, so they're back in the cockpit and they've got to do all the checks again. When we fly to the Aran Islands, little twin-engined turboprop aircraft, an Islander aircraft, only a pilot up front, and you can see him because you're looking over his shoulder while he's flying, and he will start up the plane. He'll get the thumbs up from the guys on the ground. He'll taxi the plane to the runway. He'll line it up on the runway, and then he goes through his pre-flight checks. He's looking at the gauges. He's completing he's a checklist form that he has to kind of tick off as he goes. He's throttling up. He's throttling back. He's almost turning the engine off. And then when he's ready, the clipboard gets put away and off we go. And he does it every single time. And it's an 8-minute flight. So it's not as if the plane has been flying for several hours and maybe needs to be checked before it takes off again. Every single time And every pilot does it. There's YouTube videos of the flight crew for Aer Lingus leaving San Francisco for a flight back to Dublin, and the checks and cross checks and double checks that they're putting into place. In the event of, it's on computers now, but it's still checklists. It's all this checking possible scenarios. It's making sure they've all the bases covered off and they all know what's going on. And if you look at the TV series where they have the investigations, I'd say a good percentage of them are caused where pilots have taken a shortcut. They've decided we can skip that piece. They don't do that instruction. They don't follow that procedure. And the result, they lose control of the aircraft. The aircraft crashes. Yeah, there's mechanical breaks and things like that, which then ties back to maintenance. Maybe not servicing a part correctly. So that brings you back towards cost-cutting management decisions. It becomes a chain reaction down through the whole process. But it's understanding the various scenarios is something we have to do. It doesn't matter what your industry. In this case, we're going to be looking at it from the chemical side of things. It doesn't matter what the industry is. It doesn't matter whether it's manufacturing, whether it's chemical, whether it's aviation, whether it's anything. If you watch videos of train drivers in Japan, and it doesn't matter whether it's the bullet train or the local commuter train, they are very, very strict on their whole process of risk assessment and hazard identification. And they have the simplest way of doing things. Point to it. I saw videos of it before, and I saw the guys pointing, so I did some research to know what the heck are they doing here. And it's for hazard and risk assessment. It's a double check. It's not just looking and glancing at something. It's actually by pointing at it, you are consciously paying attention to it. And you see a driver on the train, he's driving along, and he comes to a speed sign on the track. He points speed sign. He points to the gauge, his speedometer on the train, and he very often will point to a chart, which is pinned up in the carriage as well, framed in the carriage, which also tells him what speed he should be traveling at that particular point in time. But it's all done by physical pointing at it as a means of hazard identification, as a means of understanding the risks. If he's going too fast, he knows he can see it. He can see that the sign says 100. He's doing 120. So he knows that he or she has got to do is throttle it back a bit, pull her back. And it's a simple system. It's funny actually how it hasn't actually caught on more around the world. That we have this just point to it. So we have to understand that the hazards are things that will go wrong. As a calculation, a risk is a function of the probability of an incident by the severity, if it occurs, the consequence. Look at the recent train crash in Greece. What was the probability of having two trains on the same track heading towards each other? One of them is a freight train, so moving slowly but heavy, huge resistance in the actual weight of the train, huge block, like running it into a concrete block. And the other was a passenger train, which was, I believe, I read somewhere it was an express train, so he was moving. So the likelihood of it happening, you might say, was, oh, that'll never happen. The consequence of it happening was huge. The likelihood, perceived likelihood, being a lower number, reduced Sorry, so I presume that Moorgate train was the freight train.
It was the underground train that hit the buffers, and it had virtually come to a standstill. My brother was in the fire brigade and attended. He said you could not believe the way it had just folded up on itself when it was hardly moving at all.
So it was the other one just came at it and kept going.
No, Moorgate. It was the end of the line, and it was running up to the buffers.
Sorry.
It was running up to the buffers, and it had virtually stopped, but not quite stopped enough. And the weight that was behind it, the inertia, just concertinaed and folded the train up. And there was dozens. I think it was about 20 something died in it.
Yeah. See, that's it. There is that concertina effect when the thing stops. And there was a train in Cove years ago came into the station, and it was a very foggy morning, and it was just going back a lot of years now. It was a very foggy morning, and the driver thought the station was further away. This is the one report that existed, and hadn't slowed sufficiently. He thought that the station was further, and he actually launched the train off the buffers and up through the wall of the station. Now, it was lucky in that it was one of the old diesel engines. If it was like what you're talking about, Mike, your underground type of, or your current commuter type of ones where passengers are all the way up front, then there would have been an awful lot worse disaster there. But the actual engine took the brunt of it. I don't think the driver was killed, but it certainly took the brunt of it at the time, where just launched into the air. It was an early morning train, so I don't think she didn't have many passengers either on her, which is lucky. They can go wrong very quickly. And if you've got the materials, like as you said, Mike, in the Moorgate one, it just crumples. You don't have the metal, is the resistance isn't there for it. It just folds up. We can look here in Ireland back in the 80s. We can look at the Buttevant train crash. Where I believe what happened was the train was going through Buttevant, and some carriages actually clipped the platform, and it just basically, something moving hits an immovable object, and it just catapulted some carriages around to smack into other carriages and cause complete chaos. Things can go out very quick. What's the likelihood? We can say not that much. The consequences can be chaotic. Consequence number can always be fairly high, severity. But does that mean then that when we're calculating these risks, that we understate the likelihood because we never believed something like that can happen to us? That sort of stuff won't happen. And if it did, it wouldn't be that bad. Walking pace. Sure, if it hits the buffers, that's what they're there for. They'll just stop the train. They'll just bounce off the buffers, and that'll be it. There'll just be a bit of a rough stop for people, but that's fine. What do we? If that's the case, when we're looking at the risk of anything going wrong, we're understating the likelihood. And in some cases, management will understate the likelihood specifically because if they overstate it, they may have to put too much money into precautions, which they will see as money they're wasting. And this is a constant battle. This is the constant battle that we have. We've had 2 shuttle disasters, which were caused by management deciding that something was a faulty O-ring in the first one and missing heat protecting tiles on the second one were not going to be as big an issue as people were saying they would, and we would probably get it up and back safely, and on both occasions it didn't work. Then we can start arguing and pointing the finger, but that's not much good to the 7 or whoever people on board who didn't make it back and their families. Okay, we're not going to look at the activity here, but there's an activity you can take a look at and reflect on. Just looking at the rankings, so things that you might see as doing the riskiest or whatever. So there's a whole list of stuff here. So if you were to look at them, risk level, where we got the rank of 1 is the riskiest, and the rank of 15 is the least riskiest. Is the least risky. So I'd say if we were to get people to do this and compare notes, it would turn out that a lot of it will be down to perception and possibly experience. Some people might consider smoking to be the riskiest. Other people, mountain climbing or swimming. If a person can't swim, then swimming is the riskiest. If a person sees spray cans and thinks of a specific type of fluid or a specific type of gas in the spray can or specific chemical in the spray can, which they've had experience of, that might be the riskiest. If someone's a nervous flyer, well, then commercial air would be the riskiest. It's the one you don't have control over. Or if you're like me, being in planes, I've had one near miss, two incidents of lateral G, and 2 aborted landings on commercial aircraft. Touch wood, none of them ever going across the Aran Islands. But I have had those over the years. So people now tell me they won't travel on a plane with me, just in case. Lateral G is the sideways G, by the way, which is where a plane was accelerating for takeoff as they were turning onto the runway. Thanks, Raymond. Confidence inspiring. It's a look. It is. I never saw so many people reach for a sick bag than when we have an aborted landing. Yeah, have a check just before you book your flight. If I'm on it, find a different flight. Near miss was the fun one. Was well, not the fun one. It was it happened so fast. Ryanair flying to London, and we were the first time we taken the kids on a plane, and we were just flying away, and all of a sudden the plane banked violently to the right. And as he was banking to the right, there was an Aer Lingus aircraft shot under us. It was kind of that close. Okay, I'll let you off for it. Just make sure you check what flight I'm heading for first. The aborted landings are both Brussels flights. One was coming from into Dublin, and one was going from Dublin into Brussels. The first one was a squall. As we were about to touch down, the pilot came on the radio after the aborted landing and said that there was a squall hitting the other end of the runway as he was landing. He didn't want to land into it, so he took off to go around again. The second one was operational reasons, which I asked a friend of mine in the aviation industry what sort of a fob off are they giving us with operational reasons. And it turns out that operational reasons more than likely meant our plane was coming into land, and another plane was on the runway, hadn't actually cleared the runway. So if we had kept going, we'd have been on top of or into the back of another aircraft. So pilot pulled away and went around, came back again. I'm sure he was using some choice language in the cockpit. Interesting experiences, and the only time I've seen people reach for the sick bags on a plane is in an aborted landing, which I found interesting. Until I found out why, when I talk again to pilots to find out why would people do that. Has to do with the power, and just the stress factor of the power on the plane, and the feelings people get both from all the senses. You're relaxing because the plane's coming into land. You can hear the wheels go down and locked out. You hear all the clunking and clanking and so on of the wheels being extended and all that sort of stuff. And as the plane is coming down, should be touching down, so you should be able to almost pop the seatbelt and start into your phone type of thing. You hear the engine screaming, and you hear the clunking of the wheels coming back up, and the plane generally climbs out at a steep angle. And that all of those hitting people at the same time can knock, and sometimes they bank out as well, can knock the senses a little bit and upset tummies a little bit. I think it's great fun. X-rays, I did in a CT scan last week, and the thought I was having while I'm lying on the machine, typical me, was what happens if they overcook the juices, if they make it too powerful? You're relying on people to take a judgment call. So what would happen if they cranked it up a little bit more? Cook you a little bit. When you go for prescription antibiotics, you trust your doctor to prescribe the right thing. You trust you're not going to have an allergic reaction, especially if it's a new tablet you haven't taken before. And if you were to read the media, especially in America, there's big evidence of people who have received their prescription medication, antibiotics across the counter in their local pharmacy, only to find that those pharmaceuticals are counterfeit and being sold through mainstream pharmacies because they're being slipped into the supply chain. So these are the risks that we're looking at. So our perception of risk is going to vary. In America, I will guess, and in certain parts of the world, I would guess police work is seen as riskiest. You don't know when you go to work in the morning, will you be coming home? And that's the thing about these situations. We all have our own views of what is the risk level at any particular task. We consider possibly nuclear power to be a lower risk insofar as it should be so heavily regulated and procedure based that it's done right in order to eliminate the risk. But exactly, a high hazard with a low risk, we hope. But we hope everybody pushes the right buttons and does the right thing and is where they should be. But what happens when the person isn't actually there? Until it goes wrong in Chernobyl, Japan, yeah. I was even at one this morning. When I was talking to a student this morning, I was supervising them on dissertation, and he's in the logistics and freight industry, shipping industry, and he was telling me of a situation where a ship arrived in port, and customs came onto the ship and knew the captain, so that they were going through the paperwork for the ship in port. And they were sitting down going through the paperwork, but of course they were also having a little bevy because they knew each other, so they were having a little dram, a wee dram, as they would say, and went through all the paperwork, everything hunky dory, everything great. But what they didn't realize was while the customs guy was on board, and they were doing these guys were in their cabin doing whatever paperwork they had to go through and having a drink and having, as my daughter would say, having the bants. The ship had to move, so it moved to the other side of the port. So she was now tied up on the other side of the boat. And when they came to going away, the customs guy just kind of, okay, see you, so I'm out, and he went off and ran down the steps and ran off to get off the boat as he had where he had come on the boat and ended up in the harbour. Bet that sobered him up fairly quick, because he went off the wrong side of the boat. Risk there. It wasn't a very big hazard. There was people saw him do it and were on the spot fairly quick to get him back out of the water. But there's a lot of situational, as you, Mike, you mentioned earlier on, a lot of situational awareness that we have to be very careful of, because if it goes wrong, we end up in a fairly nasty situation. So for me, it's always subjective. Risk is subjective based on experience, based on perception. Nicola, your microphone's off or you hit the button by mistake. Okay, I'll take it. It's a trigger hit the cat walked across the keyboard. Okay, so they did an experiment, I suppose, looking at this, and when they got the ordering done, no problem, Nicola. At least you know the button works. And they got experts and college students. They got 30 college students in the US to do the first one, and they got 15 risk assessment professionals in the US to do this as the experts. Same list. 1 is the riskiest, and 15 is the least riskiest, or the least risky. And it's interesting to see a difference between college students, who we call civilians, and perceived experts, how they're different. And I actually don't, as a very quick glance down through it, I don't see any of them that agree. Smoking, number 2. Yeah, just smoking. And traveling by commercial flight. Oh, sorry, it's 8 in one, it's 9 in the other. Yeah, just smoking is the only one I can see there that is at the same level. College students perceive nuclear power to be the riskiest, motor vehicles to be number 4. Experts, of course, yeah, that's exactly, Mike. There's these other factors that need to be brought into play as well. So it makes it more complex. But you're on a bit of a potential negative starting point when, when you have this subjectivity put into the process, which impacts the non-recognition of various things. I mean, students think alcoholic beverages are number 5. Experts say it's number 3. Obviously, experts have had more experience of what can go wrong on an X-ray. That's number 4, but it's number 9 in terms of students. They don't see a danger, but it's not that risky. Swimming is the least risky for students, whereas experts say it's mountain climbing. It's interesting to see the differences. And this is where we run into problems. This is where things can go. Even if an expert comes along and starts, I mean, what's an expert going to do if they're using this list and they're making reports, they're drawing up reports? Well, motor vehicles, they see it as the riskiest. So policies and procedures will be drawn up. They'll be drawn up around motor vehicles, the use of motor vehicles. But the users, i.e. students, don't necessarily see it as being the same level of risk as being identified by experts. So what is the likelihood that if we take college students as the users, what's the likelihood that they would be willing to implement the various procedures and controls that are put in place by experts? This is where people start to find workarounds and start to find shortcuts and start to learn where the fuses that they can take out of the vehicle that'll stop it running if there's no seatbelt put on, or turn off the alarm on it. And again, there's stories, there's investigations of issues on aircraft where they pull the circuit breaker to kill an alarm because they get sick of listening to it. Instead of reporting it or fixing it or aborting the flight, They just pull the circuit breaker so that the alarm doesn't go off anymore. And it doesn't have to be an aircraft. You get the same thing happening, in trucks and buses. I was told when I started driving by a person, started driving trucks, a mechanic came in one day, just looking over the vehicles to make sure they were all okay. And I was at my van, I don't know, I was doing my stock or something at the end of the day, and he just came and was chatting to me. And he was asking what I thought of the van, which was fine. So it was a van. I was getting used to it. Mentioned the fact that I noticed it was governed. It only went to a certain speed. And he showed me where on the fuse box I could pull out a fuse, a blue fuse if I remember rightly. And he just said, if you take it out, put it in your pocket, and always keep it with you. If you ever get stopped, push it back in. But once you take it out, you can drive at whatever speed you like. Probably something he shouldn't have told me. But, there's a way around these things. He obviously didn't see the same level of risks that the company who manufactured the truck saw by putting the breaker in or the fuse in. In industry, we have to be mindful of that. You have people who are 10, 15, 20, 30 years doing the job and actually did the job before half the safety stuff came into play and don't see why they need to do it now. It's just more red tape. It's just more jobs for the boys and the girls. It's just more hassle. It's more money. Just looking at the factors there, of the top three, so the nuclear power smoking, for these experts, nuclear power was number 12. For college students, it was number 1. Smoking was the agreed number 2, and the experts saw motor vehicles as number 1. That thing should have reset itself to 1, 2, and 3 again. And smoking is number 2. You see the positioning on the chart. So our perception then impacts our risk assessment. Besides our best guess of what the likelihood and the consequence, which is our emotional risk, which somebody mentioned that earlier on. The emotional risk perceptions. What's involuntary versus voluntary, what's immoral versus moral, or unfamiliar versus familiar. Familiarity, as the saying goes, breeds contempt. The more we are used to something, the more we do something, the less likelihood we'll follow the rules. Because it's worked fine every other time. And production managers or senior managers will have us breaking rules. How often has that actually gone wrong? How often have we seen one of those fail? How often has this actually ever blown up? Never. Well, then it's not going to blow up this time. Just get on with it. But there's a procedure. Forget the procedure today. We don't have time for the procedure. And once we break the procedure once, that's it. We're breaking the procedure all the time. It's going to continue. So bring this into chemicals. What should we then look at as professional risk assessment? I mean, chemicals are the type of things that can cause all sorts of problems. Union Carbide, back in the 90s, I think it was, in a little place in India called Bhopal, where thousands were killed or seriously injured because they vented chemical gas inadvertently, but they still leaked out chemical gas. And there's still people, I believe, suffering from long-term effects of this. It was like a nuclear war zone when it went off. It just leveled the place. Not the buildings, just the people. I took a lot of legal action to get anything back out of it. The chemical spills cause panic for people. Chemical issues cause panic. The EPA they're still paying. I wouldn't be surprised, Mike. I wouldn't be surprised they're still paying, because first of all, it went on so long before they were actually held to account for it. The legal battle went on for so long for them to actually finally be found guilty in the situation. But then, yeah, I'd say they'll be paying for a long time. Most of the pharma plants in manufacturing plants, so there's a big concentration, a cluster of pharma manufacturing in Cork, in a place called Ringaskiddy, in Cork Harbour. It's a little peninsula in Cork Harbour that juts into Cork Harbour from Carrigaline. And EPA and residents in that area are actually very, very, very strong. They are constantly taking samples of the water, the harbour water. They're checking for quality of the water. They're checking for effluent from the pharma plants, which have all the big guys there. And I remember when the Novartis was opening there, I was going back 20 odd years now, 30 years ago. We had a person staying with us who was a chemical engineer student, friend of mine, a first cousin of mine. She stayed with us for the summer because she was working in Novartis as part of their calibration, their setting up process. Yeah, most of these companies get bought out, Mark, on the way there's always these takeovers going on. Chances are they got bought out to basically get rid of them, so that a new company could come along and bring in new management and start clean, try and return some reputation to the place. It's a strategy that's done so, and also a company looking to acquire someone like Union Carbide would get them cheap in relative terms because they're damaged. It's a damaged property. It's a damaged goods at this stage. So management of Union Carbide, owners of Union Carbide want to get out because their reputation is shattered because of Bhopal. So somebody will come in and pretty much get them for discounted price just to get rid of them. We've seen it in a couple of different companies. BlackBerry was sold out. SVP sold out very cheap today, a pound. Jibs, I could have bought that myself. BlackBerry sold out for essentially what was loose change in somebody's pocket, because they missed the whole smartphone thing. SVP is just proof of the fact that even with big success, the fastest growing industry in the world is IT, and even with that, things can go wrong. Risks happen. Stuff doesn't go according to plan. Share prices get impacted, and that causes panic. Take all the liabilities, which means you have all the bills, but then what you hope to do is you clear the bills, or you settle the whole thing back down again. It all recalibrates, sets itself up, and you then can cover the bills and you're making a profit out of them. So it's a cheap investment if it all pans out. It's a big headache because you've taken the liabilities if it doesn't pan out. Unfortunately, for example, BlackBerry didn't pan out and they're essentially gone. SVP, we'll have to wait and see. If is a small word, yeah. And what does somebody say? If only for if, we'd be happy today. If is the thing that can cause a problem. But have to also, well, you see, the thing is, we can say that I don't believe HSBC would make stupid decisions, but we can get rabbits in the headlights. Well, committees make up the people who run these businesses, so what's their view on risk? Obviously, their perception of risk isn't that big at the moment because they decide to go after for the price, for a quid. Take it all over. SVP can wash their hands of it and walk away, and somebody else takes all the problems on. Sometimes it works, sometimes it doesn't. The horse meat scandal that happened here in Ireland a few years ago resulted in Silvercrest Foods pretty much going to the wall and being taken over by one, I know, was it Kepak or ABP, one of the beef producers in the country. And it was taken over as not for a quid, but it was taken over very cheaply. And because the opportunity is there, we can take the technology, we can take the operation. We're now going to rebrand it as a new name, new company, new everything, and we get rid of the people we want to get rid of, and we start fresh and we rebuild. But we have all the resources we need. We're now into a new industry, or a new area of industry that saves us having to invest to set up in it. We bought it discounted. There's benefits in it. But for companies to do that, they have to have a good risk perception. Their perception of, the likelihood versus consequence. The likelihood that SVP are as bad as people think they are versus the consequence of paying a quid for it, and we're taking the liabilities, and the whole thing goes pear-shaped. And we're literally stuck trying to have to resolve all this and pay for it. I'm sure there were people on their committees or their board who were not happy to put that risk in. You may have people in HSBC looking to cash in and get out of their investment bonds, or the broker agencies who may have things like pension schemes through HSBC may look to cash in on their portfolios because they don't want the risk of taking over a bank that's essentially going bankrupt. Because there's been a run on the bank. Arguably, we'll see a lot more of those risks, because the more we go to a capitalist society, the more we're going to end up with a situation of potential lack of cash funds in the world. It's long been broadcast that if everybody in the world went to their bank to take out whatever savings they had, there isn't physically the amount of cash in the world to give everybody back their money. So that's what happened to SVP. People just started looking for their money, and they realized that they had a run on the bank, basically. And they couldn't meet it. They couldn't liquidate it. And the more that they couldn't liquidate it, the more panic that created. It just became a snowball effect. Yeah, Northern Rock had the same thing, yeah. Remember seeing the videos of the news reports of the queues around the block looking for people queuing up to go and get their money out. And that triggered off a whole host of other issues. It's one of the problems that's there. The banks don't have physically, the physical isn't the amount of money in the world to give back to people. So we're working on moving a number, the Father Ted approach to accounting, just resting in my account, or the Anglo-Irish Bank model of accounting. We just move it from account to account to make it look good. It's all fictitious money, which is kind of unsettling. So we have this emotional situation. A risk concept for both safety and security. We need it both, obviously, in chemical management. Safety, you're looking at things against spills, accidental exposure, uncontrolled reaction. And security, there's always a risk in terms of any sort of chemical product of theft, diversion, intentional release, sabotage. Chemicals are used across the board. They're used for good, peaceful process, but they also can be used for illegal processes, as you know. We have to look at both of them when we're considering risks in that industry. And again, those of you who are already working in that will know these situations. You've got to look at both. no such thing as a safe chemical location, and yet you come across situations where safety features and safety protocols are not followed. You had the big chemical spill or the derailment in America a few weeks ago. I think it was in the Midwest or somewhere in America, where the politicians were even turning up to walk through towns that were affected to try and show that the air quality is fine, despite the fact the residents are complaining of smells, taste of the water, and whatever, because they believe the chemicals have contaminated both the air and the water and the ground in the country or in the area. So what we do, we send ministers in and let them walk around and take a few deep breaths and prove that it's all great. And once they leave, once they get out there in their cars, we'll give them oxygen to clean them up and flush them out again. In parts of the world, you can have a lot of attacks on chemical facilities. You have petroleum sites being targeted. You have over-the-ground pipelines running across countries, and you have people coming trying to siphon off fuel, which then causes somebody lights a match to see where it is, and there have been incidents over the years where people have been killed. Numerous people have been killed because of an explosion caused at a pipeline where somebody was there trying to break into the pipeline to physically siphon off fuel. The type of things we look at when we're talking about this safety risk at chemical organizations is we've low, medium, and high. At the low level, we're looking at various routine procedures, staff trained, experienced, materials used are generally benign, or used only in micro scale amounts, and an incident wouldn't generally be that big of an emergency. Unless, of course, the media gets hold of it or social media gets hold of it, and all of a sudden it becomes blown out of proportion. At a moderate level, the procedures may not be routine. Staff may only be partially trained and have limited experience. Maybe materials that we're talking about here are reactive or flammable or toxic, or present in moderate, there are larger quantities of it around that can cause a problem. And at a moderate level, an incident would constitute into an emergency. And obviously the high version is Armageddon. Procedures are novel, extremely delicate. Staff may be untrained, inexperienced. Materials are highly reactive, toxic, explosive, or present in large quantities. Processes under high temperature or under pressure. And the incident would be life or facility threatening emergency. There was a situation a number of years ago, I think in the mid noughties or into the early teens. It was a container ship coming from America to Europe. And it was I think it was in New Orleans, loading up, somewhere in the Gulf of Mexico, loading up. And it was during the summer, but it was unseasonably hot temperatures. And the ship itself had two storage areas. It had below deck, which could be sealed with covers, and then above deck could be stored on top of the covers. And containers were loaded. It's nothing unusual. Containers were loaded according to weight, according to where they were going, and some consideration about the loading process. And what they didn't realize, and it's amazing they didn't realize it, was they knew what the containers had. They knew that there were chemicals on some of the containers and there were materials and products on other containers. But what they didn't seem to understand is the impact temperature had on the products. These were sitting on a quayside at getting on for 40 to 50 degrees C. Now, one of the chemicals that was being moved was very volatile, extremely volatile. But when it's being transported, it would have a stabilizing agent inside in it. So they would add something to it to stabilize it so it's safe for transport. And they considered that was fine. What they didn't factor in was that it was sitting in a container on the quayside in 40 to near 50 degrees temperature for, I think, 3 to 5 days before it was actually loaded on the ship. I don't know what the issue was with getting it loaded, but there was a delay getting it loaded. And that temperature reduced the effectiveness of the stabilizing agent by a factor of over half. It actually made it a very unstable situation. The container was put below deck, and then the seals were put on, the plates or the covers were put on, steel covers were put on over the hold, which sealed in those containers, and then they put more containers on top. The problem was that now we've got an unstable chemical product below deck, which is releasing, because the stabilizer is not working, it's releasing toxic gases. And that mixed with toxic gases, or the fumes and the gases coming off other products in other containers that shouldn't have been stored anywhere near these chemicals, but there didn't seem to be an awareness that they shouldn't be put together. They were just storing based on destination and weight and so on. And these reacted in the pressurized, or in the basically the confined space of the cargo hold, which was sealed, caused a fire, which they were halfway across the Atlantic when the alarm started going off. And it was they were even commenting that it was a flat calm transit, something they had found very rare crossing the Atlantic, to have very, very calm weather. And next thing, there's a fire. Everything should be just plain sailing, just get across, moor up and offload. The resulting fire caused the ship to be abandoned, caused 4 crew members to lose their lives. I think at least one of those crew members was never found. The ship essentially burned itself out, or burned out a lot of it. They couldn't actually out the fire, basically. They had to just let it consume and then take the boat under tow and get it into a port in Spain or Portugal or somewhere. The thing that I find is that these were supposedly chemical expert people used to handling equipment, handling these materials, who had the training. 3 dead, 2 recovered. I thought there was a 4th guy died on it, Mike. I thought there was another guy died subsequently. That there had been a guy rescued, but he'd subsequently died. But maybe it was only 3 and 2 found. What gets me though is that, you would think that these are people who know how to handle and how to manage and move this equipment. And it was a chemical engineer came in and was looking at the investigation and pointed out they'd actually missed the fact that the stabilizer was essentially worthless because the containers had been held exposed in the temperature. The Flaminia, yeah, I knew the name is familiar. Unfortunately, it's a very apt name for what it had. flame. It just, these, as I said, these are experts, supposedly. These are people supposed to know how to handle the equipment that they're carrying, or at least have access to that information. So maybe you put them here under the moderate. The procedures wasn't routine. There was a delay in the loading, so the thing was sitting there for longer, and there's a bit of an urgency to get out. Staff are only partially trained, so they knew how to handle emergency equipment, but they didn't realize the danger they were putting themselves in by mixing two separate type. One was something like putting this chemical with polystyrene, and the two of these, the vapors given off by both mixed and became very combustible in the heat of the ship, in the confined space of the cargo hold, and it just set off, just triggered. That's quite spontaneous combustion, but there was a fairly quick flashpoint. This is something that happened in relatively recent. Mike has up the link there to it. The Flaminia papers dated 2012, 14th of July. They tried to fight it using all sorts of stuff, carbon dioxide and whatever, to try and fight it, but she just didn't work. So thanks for that, Mike. Thanks for putting that up. I'd seen a report about it. Again, these are people you expect who will handle products and will know how to manage this shipping, know how to manage varying products. That's what they do. That's what MSC does. That's what Hapag-Lloyd and all these other container companies do. They're supposed to know how to handle these things. They're supposed to know what they can mix, what they can put with what can't be put together. It's the ultimate seating arrangement for a wedding. You can't sit this person next to that person because they're volatile against each other. Well, you can't put that container next to that container. It just amazes me that these things don't get, they just don't get picked up, or there are people just ignorant to it, or we're not paying attention to it. We're not experienced in it. Never come across it before. When we think the world is a safe place and everybody knows what they're supposed to be doing, and then you have something like this with 3 people killed, and one is never found. It could have been an incinerator or went overboard at some point. It must be a scary situation on a ship when something like that happens, and you can't get it under control. You're surrounded by water, so it's not as if you don't have enough water to throw on it, and you end up leaving the ship. We're taking a look at the risk categorizations. So we've got the initial part, looking at the low, moderate, and high. Now let's look at it. The security rather than the safety. Well, low risk is the assets are possibly targets of theft or diversion, but if it does get stolen, it's not a major issue. Now that's something that's a little bit, people thought that stealing fertilizer wasn't a big problem until certain organizations started making bombs out of them. So they use chemical fertilizers to make explosives. There are clever people out there who can use chemicals for different purposes. A moderate security risk, the assets are attractive for theft. They're the type of thing people want to steal. Maybe they've got other uses, such as explosives, or they help in the drugs industry, or they just have a high monetary value. They're worth a lot of money. Person I had as a student a number of years ago in undergrad level was telling me of a big issue that they have. She worked for a global pharmaceutical manufacturer, and it is a huge industry of parallel imports of pharmaceuticals. So they would send a batch of pharmaceuticals to a hospital in some part of the world, and it would never get there because en route it gets stolen, and then it gets sold to the hospital from a different supplier, the exact same product, the exact same batch, but at a different price. The hospital is now desperate for it, so they end up paying more money. So it's almost like holding it hostage, and then selling it on in that grayer market. It's not counterfeit, it's genuine product. It's just not coming in through the proper channels. But the risk for the hospital is if we don't take it from somewhere, even on the black market, then we have none. And if we have none, we can't treat patients. So which do we want to do? Treat patients and get our materials wherever we can get it from. So feed this moderate security risk. Or do we refuse to supply and therefore put our patients at risk? The consequences can threaten the public. We could have misuse, which can be harmful or even lethal. So there are things that can go wrong. It can also damage reputation. Organizational reputation is a hard one to rebuild. It can be done, but people will generally never forget it. One of the reasons I'd say Union Carbide has disappeared was because they'll always be associated with Bhopal. So, it's worth getting out of the game at that stage. High risk from a security perspective is where your assets are valuable, maybe hard to acquire, or could be used for more than one purpose. And the consequences of misuse would be harmful, possibly even death of numerous people. The doomsday scenario of contagion, the doomsday scenario of releasing a chemical attack or releasing a virus, some sort of a chemical situation that would cause a major security risk. There are the conspiracy theorists who believe COVID was all a security risk issue. That this whole virus was released to shut the world down, to destabilize everything. And oh yeah, by the way, that gives us the opportunity to move things and do things with nobody watching because we're all locked. Everything is locked down. People will make a value where there is none. The point is, we need to look when we get to something like pharmaceuticals, the chemicals. There's both the safety side of it, the safety risks, hazards, but there's also the security hazards. Things that can go wrong. If the system is abused, and consider the fact that, good idea, yeah, we'll do 1 second, Mike. We think about the fact that, these risks are all around us. It doesn't take much to cause a panic. And media will take over, just start it, and media will take over and do the rest. Okay, can we? Yeah, well, that's thanks for that, Mike. Medical knowledge. Okay, we take a break. Maybe, well, it's coming up to 8:30 now. So I was going to say 10 minutes. It's going to be back here for 22. give people a chance to boil the kettle as well. So back here for 20 to 9. Talk to you shortly. Very posh, Mike, heading for the wine. I'll stick with the diluted orange for the moment, because if I start the other stuff, you don't know what I'll be saying. Okay, folks, we'll get back into it. I hope the boiled wine was good, Mike. And we'll get on with this. So we're looking at two different angles here in when it comes to safety in chemicals. We're looking at the actual safety risks and the safety concerns in relation to the consumption or absorption or whatever of toxins. But we're also worried in this industry on the security risks and the issues around the security of protecting these. And some of that comes down to a local level. I mean, very often on local sites we would hold stocks of chemicals and we have to store them in a certain way. If you're storing large containers of them or large tanks of them, you have to have various bunts around the place to protect from spillage. You've got to have all the facilities, the procedures, the training there. We used to have in the factory, we were a meat plant. We used to have in one place near literally outside the office door of the site, medical center of the site, the nurse's office, in the corridor was a shower. And the idea was if somebody was contaminated, they'd have to literally stand there and be showered off before they walk in the door of the medical area. Always struck me as a bit strange that this thing is in the middle of a corridor, but it was an area where there was a true flow of air, so it was reducing the risk of confining a person with potential chemicals on them, and it gave emergency response to somebody in the event of something going wrong. Biggest issue I had about that whole concept was the production facility was a good distance from the actual location of the shower. So if somebody in most of the production departments, apart from the high risk department, if somebody in any of the other departments had become exposed to a chemical, they had to come all the way through the factory to get to where that shower unit was. There was no other showers in any other part of the factory, to my knowledge, unless they were hidden somewhere and it was just never been told where they were. That to me was a bit of a design issue. But thankfully, I've actually never saw it being used or heard of it even being used. It was just something I think that was put in as a precaution, possibly because it was more than a nice to have; it was a must have. So we need to categorize our security risks. So what are we looking at? We've got to look at our chemical security. The risks, we've got to look at how we're going to reduce the same as we would do with any other type of risk. But I suppose we have to put a bit more than just pay a cursory hat tip to the process here. When we're dealing with chemicals, we've got to pay a bit more attention to it. I suppose the one thing we have to recognize, that's true for all risks, is it's very difficult to reduce risks to zero. In most cases, we just try to manage them as best we can, because no way we can reduce them to zero as having infinite space, infinite facilities, infinite training, and infinite money to pay for it. And that no company has that. So we can't ever accept that's going to go down to zero. Can't necessarily fully eliminate in chemicals. It takes one mishandling. I was offered a job and it wasn't a chemical situation. It wasn't a result of a chemical per se. I was offered a job August, actually over the course of the summer of 1993. I was offered a job in a pharmaceutical plant as an operator in Cork and Ringaskiddy, small plant called Hickson's, no longer existing. My father-in-law had been a foreman electrician in a different pharmaceutical plant, and he had been on to me from the day I started going out with his daughter that I should get out of the food industry and I should get into the pharma sector because the money was better, the hours were better, the conditions were better. And if we were living in Carrigaline, it would have only been 15 minutes up the road, and life was going to be better. And he sold it to me, and I went after it. And after a lot of toing and froing, because at the medical they found a hernia, and I had to get that dealt with. And once I had that dealt with, then they took me in. I handed in my notice on the 6th of August 1993, a Friday morning at about 6 o'clock in the morning when I was in the Cork depot. I went into my first call, and some of the guys, there was another guy in van sales in a different company, a bread company. We kind of turned out in our conversations that we were both up for the same, we're both going to the same place at the same time. So we kind of met that morning. Well, did you hand in your notice? Yes, I did. Oh, great. So did I. And very quickly, people started making kind of joking words. You're going to a chemical plant. Did you say you're going to a chemical plant in Ringaskiddy? Yeah, haha, just blew up. Which, yeah, right, whatever. It actually had. It was, there was part of the building, part of this facility being renovated or being adapted, and workers working on putting felt on the roof had a blowtorch type of thing and didn't manage it, didn't control it, put it out of their hands for just a second, close inverted commas, and apparently it set fire to half the building, which was the half the building that myself and my colleague were supposed to be starting work in. So job was gone, essentially. So you can't ever reduce it to zero. There's always going to be something can go wrong. Somebody just absent-mindedly puts something down. Somebody lights a cigarette where they shouldn't. Somebody forgets the fact that it's extremely hot right now. It's unseasonably hot weather, so they put something down in the box in the heat and forget the fact that the heat on the outside will have a superheat effect on the inside of the box, and it will cause a problem, as happened with a hip replacement that was being sent to Australia as an urgent request from a hospital in Australia for surgery, being sent from Cork and got as far as Dubai, was put beside the plane so that it would be the last thing onto the plane and therefore the first thing off of the plane. Unfortunately, beside the plane in Dubai means that you're putting it on a trolley in a desert, in desert heat. And the product was a medical product, so it was packed within a box, within a box, within a case or box type of thing, which created a double or triple magnifier effect on what was actually on the inside of the box. The product, the hip replacement product, the kit. So when they got it into the hospital and they opened up all the cases, they had this lump of melted titanium because of the magnifying effect of the packing for a box and a box and a box. We can't reduce the risks to zero. Things can go wrong. Things we can think of. Ireland, come on, we don't think of the impact of 50-degree temperatures on something. We don't get 50-degree temperatures, so it doesn't cross our bows at all. So in our supply chains, I'm always saying that we need to know our supply chains. We need to know where the potential issues are so we can manage it. And it's the same thing here. There's always new chemicals. There's always new processes. There's always new things being discovered, which will impact what we do, will impact the way things are handled. So we have to start categorizing, as we do with every other risk, every time we do a review, just that we focus on the chemicals, because there's a lot more at stake if we get this wrong. So we're trying to find ways of reducing risks as much as we can, as we do in every other process. Large effort made to reduce high risks and smaller effort for lower risks. And that's even down to how we store products. certain products can't be stored indoors, certain products can't be stored outdoors, certain products have to be stored within certain conditions, certain temperatures. And if the temperatures are impacted, well, that can cause a problem. The cold snap last week could have had an impact if products have been stored in a different location, stored in a different way. If nothing else, at the very least, it can actually impact the functionality. It can reduce the effectiveness of a product. So the types of controls that we can put in place, we have our administrative controls, paperwork, reports, instructions, documents, operational controls we can put in place. And from the operational side of things, we have just procedures, SOPs. Engineering, we can construct something, we can produce something that will protect. We can have special rooms, special holding areas, special handling equipment, things that are all there to try and reduce some of the risks. We're trying to, and of course, there's obviously PPEs. PPE should be a whole system that we have anyway. That should be, you'd be surprised how many companies don't. The companies that actually don't, they cut corners on some of that stuff. And sometimes it's the bigger companies. That's one of the big ones, Raymond. SOPs are always, and unfortunately, companies have a habit. And again, I'm not trying to tar everybody with the same brush here, but it is an issue that companies will draw up an SOP and then they do the washing of the hands view of the fact that, well, that's us done. We've done our bit. We've put the rules in. Now it's up to people to follow the rules. And then we hide behind the fact that if something goes wrong, that's when the rule books come out again, the SOPs come out again, and we just go to prove the fact that somebody didn't follow the procedure. So that we look for scapegoats, we look for someone to blame. Whereas SOPs should be policed, SOPs should be managed. But are they managed? The answer is no. Not the way they should be. I've been in organizations, I've seen the SOPs gathering dust on a shelf. And it's not just for the handling of things like chemicals or the procedures needed to actually maneuver chemicals, where somebody's supposed to put on the various PPE gear before they go and handle it. And you look someday and there's a person with no gloves or no PPE gear or no masks, and they're just handling it. Just what's going on? I didn't have time to go get it. I mean, sure, I'm only moving it a little bit. It's okay. Should we do it all? We do it all the time. There's a statement that we'd love to hear inside in any sort of hazard assessment or hazard analysis. Should we do it this way all the time? Why all of a sudden do we need to put all this other stuff in place? It's on the SOP. Yeah, there's lots of stuff on the SOPs. And in management are as guilty as this as anything else. As I said before, what happens when there's a rush going on? What happens when we need to make the ferry, the tonight's sailing to the UK, and the truck has to go now to get through the paperwork to make the sailing, to get through the customs and all that bits. So it needs to be loaded and out the door now. What happens to well, we need to make sure it's stored this way, it's processed this way, it's sealed this way, before we release it. That's what the SOP says. What happens when management says, look, when was the last time we had an issue? Well, we haven't, because we followed the SOP. Yeah, but when was the last time we had a near issue? Well, we haven't. But sure, we haven't used the SOP in ages. That thing hasn't come off my shelf since I arrived. So we don't use the SOP. So why all of a sudden are we having to use it? Just get on with it. Just do the job. Get the thing on the truck. Things like that happen. Human beings by nature will find the shortcut. We will find the workaround. And a piece of paper that says you should do it in a different way is only used by and large by companies as the legal protection when something goes wrong. Wrongly, but that's what happens. When you arrive or when this comes in first, everyone's put through a training process. Everybody is made to sign the document to say they have been shown how to do this. And that's the last we all hear about it until something goes wrong. In a chemical situation, that is actually a big, big problem. You're actually, in some cases, relying on a chemical situation. You're actually relying on the dedication and the attention to detail of the operators than potentially the proper implementation of processes. Unfortunately. And yet it's something that we have to look after. It's something that we have to do. We should be doing more. I'm not saying everybody is a problem here, but it doesn't take everybody to do this. It takes one incident. And consider that the vast majority of the incidents that happen are down to human error. As somebody said here on the first night, I think, of the module, there's no such thing as an accident. It's a series of unforeseen incidents. But arguably, even unforeseen is an incorrect term, because they could be foreseen. They could be things that we know, because we're not following the procedures, that we're increasing the risk of something like this happening. And this is what we're up against in our industry, in every industry, not just chemicals. As I said, watch any of the programs where, in engineering blunders, or any of the programs, the documentaries that are on, and just see what goes wrong and where. And the vast majority of them are human error. Somebody not following procedure, or somebody not being trained correctly in a procedure, or a system changing and the procedure not being updated. I mean, in the medical sector, there's a book, or a public, I don't even know if it's a hard copy. It is a hard copy book, because I've seen my GP with it, called the Pharmacopoeia. Essentially, it's a pharma encyclopedia. And if memory serves me correctly, going back a number of years when I actually was involved in this game, it's issued, I think, twice a year. And this is a multi-volume book. It's every single drug, every single pharma product available on the market is in this book. And it's like a dictionary. You go to the drug, and it tells you all of the stuff that's in it, what it's used for, what are the contraindications, everything about the product. And the reason I remember it is I'd heard about it in my last job, and I was sitting at my GP a number of years ago, and I had a very bad chest infection, and they were looking to see what the heck they could give me. And the GP took out this book, one of the books. He had a whole rake. He had a few of them on the shelf. He took out one of them, and he started going through it, and he found something. Oh, I think I want to give you something, but I want to check it first. And he opened up this book, and he found it, and he went, "Oh no, I can't give you that because you already have this. Or you already take that medication. I can't give that. Okay, need to. But there's a note. Try this instead. Okay." He went off to try something else. these are changed every, these update as new contraindications, new issues come up, or new benefits come up. They're finding things that you can be used to treat one thing are now showing signs that it can be used to treat dementia and stuff. There's always new medications coming out or being signed off that are being added to the list. There's other ones being taken off the list as being less effective. So, things change, processes change. You have to stay the latest operations. Chemicals change, the way they're stored, the way they have to be handled, because maybe there's a stabilizer now being added into a chemical which makes it safer. Maybe it doesn't need the strict temperature control that it used to. The initial COVID vaccinations that came out, which are chemicals, required to be stored at something like minus 40 degrees. The second batches of them that came out, the other manufacturers who brought them out, they didn't need to be at that temperature. To the point that when I got called to get my vaccines from my GP, they were sitting in boxes on the table. Just take a vial out and stick a needle in it and, stick it in somebody's arm. It didn't actually need to be refrigerated. There was nobody in a hazmat suit going over to take out a small vial out of a freezer chill to bring it over and inject a person with it. I was actually hoping it would, because I want to know would it feel cold being injected, which it didn't. It was boring. So we're trying to reduce these things, and the only way we can reduce them is have everybody on board. And the weak link in the chain in any sort of risk management, whether it's for security or for the safety of the product, the weak link is carbon-based life forms, humans. Not following these 4 points, administrative, operational, engineering, or PPE, not taking the steps to reduce the likelihood or decrease the consequences from it to make it safer. So packing things in smaller containers so that if anything does rupture or spill, it's not going to be as big an issue as if you have a 500-liter container that's going to leak, especially if it's a corrosive product. So what we're working on, as we'll be going to more of this next week, we're going to wrap it up in a few minutes, is we're going to start looking at the safety assessments. We're going to look at the security risks, and then we'll draw some conclusions. So we're just going to make a start, because it's only 9:05. I'm going to make a start tonight on the safety side, and then we'll stop, and after a little while, we'll continue with that then for next week. So we have a process. There's always a process, and all of these processes they're all the same. They all follow the same routine. You start by looking at the job. Any risk assessment, you start by looking at the job. This is to do with the safety of the product, the safe handling, the safe storage, the safe management of chemicals. If you're looking at the safe operation of people working at height on scaffolding, you start the same way. You look at the job and you identify the hazards. We've done this already in our modeling with the NHS and the other tools we've looked at. They all follow the same process. Identify the hazards. Characterize safety. And then ask the hard question. Are the risks acceptable? That's a yes/no answer. If they're not acceptable, then we got to go back and we've got to put additional controls in, and we've got to go back and start again. When we put these additional controls in, we examine the job again, identify the hazards again. Are the hazards the same? Are they different? Are they worse? Or are they better? And work on down the line. Once we keep going around that right-hand circle, we keep going until the answer to number 4, ask the whys exactly. The 5 whys. Keep asking. It's almost like the annoying child. Keep asking. When I think of the 5 whys, I think of the annoying child. Not that all children are annoying. I know most of them are saints, but the 5 whys of, you can't have that toy. You can't have those sweets. But why? Because you're going for your dinner now, and you can't have sweets before your dinner. But why? Children are great at asking the 5. Actually, children are great at asking the million whys, not just 5 whys. 5 whys would be a short conversation. But you keep going until you get to, are the risks acceptable? Yes. But that's not saying that the risks are eliminated. That's just saying that we accept them. They're at a level that we can manage it. You can't, you work on you have a building site, or you have an industrial facility, and you have people working up in the gantries up at height. You can't all of a sudden remove that task. You will need periodically people to work at height, up in a high area. My daughter, when she studied in college, she studied music engineering and music production and sound engineering. And that meant if she was in a theater, she would have to be up along the gantries running cables. She'd have to run part of the sound system to make sure that the microphones and all the things, whatever, are all hooked up correctly, and lights are all hooked up correctly, and all that sort of stuff is all done. So that meant she was up along the gantries over the theaters. And she had her cables and all her other safety situations. But there were also times she said that she wasn't. She was just walking along this gantry, and there was no cabling. There was no, lifelines or clip-ons or any of that sort of stuff that you use to run yourself, cables that you run yourself along for security. It was just get up and get it done. And it was bring a roll of insulation tape that you can tie things together with. It was cheap and cheerful, which is one of the reasons that she doesn't do it anymore. She basically said this is the operation she got herself exposed to, as far as she was concerned, were cowboy operations, and those guys were professional theaters. But what she was being shown and taught was budget cutting version of it. For them, the risk was acceptable because nothing ever went wrong. Nobody ever fell off the gantry. Great, congratulations. From a health and safety perspective, you can argue that means you've been lucky, because you don't have the facilities there. But what you have to do with any type of job is, if you get the acceptable level of risk, so you get the risk where it's you've taken the precautions you can take, and you're now happy that it's as good as it can get, you go on with the work. And this is where companies sometimes drop the ball. You then go back and check it. You follow up with periodic repeats. Sometimes that's considered, look, we're just so busy, we don't have time. Or, sure, why would I poke that horse? Why would I open that can of worms? I'll just leave it. It's working. We'll just keep going. Don't question it. Don't rock the boat here. Why would you look under that? Much better to just, we did it. We have done the test. So from the ISO perspective, from all the quality managers, the HSA perspective, we've conducted our checks. We conducted our analysis. We identified the hazards. We characterized the safety. We put steps in place. We now consider it acceptable, and that's what we're doing. When did you last run the test? It would have been before COVID. Okay, it's the same person doing the job now as was the person who was doing it 3 years ago when COVID kicked in. No, the person who was doing it originally is no longer there. This is a new guy. He's only with us since Christmas. Yeah, so have they been trained in it? Well, we went through the process with them. There's a couple of the inspectors that I know of, are they're quality assessors, and what they do when they go to when they want to conduct an investigation is they will not talk to management. or they won't talk to management for most of the investigation and the audit. What they will want to do is talk to workers, people doing the job. And they will go, they don't care what the reports are. They'll want to look at the reports just to see that they're up to date and they've been completed. But what they're actually interested to do is talk to the operators, talk to the people doing the job. And they will quiz them. They will ask them questions on the procedure. Why are you doing that? What is the next step? What would happen if? When was the last time something went wrong? What did you do? And they're gauging the audit based on the responses. So they're talking to people who are dealing with the safety issues, dealing with the chemicals, dealing with the processes on a daily basis. And they're not worried about your SOPs. They're not worried about what you say you do or what you have everybody signed off on. They're interested in what's actually happening. And they're doing it without the presence of a manager. So they have the person there on their own. I did it totally different situation, well, it's slightly surreal situation for what is now SETU when it was still IT Carlow, or 2 years ago. I got asked to audit a training program, and I was sent. It was in the military, in the army, and I had to go to the Curragh early one morning to be picked up by a staff car, and I was driven to Cork, to Collins Barracks in Cork, and all saluting and all sorts of fun stuff. And what I was doing was, it was a training program validated by IT Carlow at the time in the use of short-range missile launcher, a portable short-range missile launcher. I had the name of it at one stage, I've forgotten what it is. It's a Scandinavian product. And I had to audit the training and use of it, which is a bit surreal. You're kind of sitting there and you're watching guys practice using a soft an anti-aircraft missile launcher. Didn't even know we had them in the army, but we do. When I was conducting the audit, there's 2 occasions when it happened. There was 2 different procedures that I was auditing. I was in a room, and a selection of the students, soldiers, were sent in one at a time to me, so that I could quiz them on the use of the piece of equipment and the training, to gauge their views on the training. And I asked them different questions each time. Each person got asked different questions, so they couldn't come in and kind of, we'd all say the same thing now would be grand, or I'd ask the same question in a different way or in a different order. Not to catch them out, but to catch them out, to make sure that there was a consistency, but it wasn't a case of, well, this is what he asked first, this is what he asked second, because in the military things tend to be very routine. So mixing it up a little bit kind of helped. And this is what we need to do. This is what an auditor will do. They will check, and I thought it's a brilliant idea. You want to check with the operator without the presence of managers or supervisors or colleagues, because you do not want someone standing behind you holding up a cue card type of thing to help the person answer the question. You want to make sure that you are managing the process correctly, and you're doing it by getting these people to respond to what's actually happening. If you were conducting an assessment and you're asking people questions, and they can't, when you're doing your periodic review, and they can't answer the questions, then you need to go back and say, you should be starting it anyway again and rerunning it, because operations change. 3 years ago last Sunday, the world changed forever. 3 years ago last Sunday, the day before yesterday, 3 years ago yesterday, I'm forgetting what day I have, 3 years ago yesterday, 12th of March, 2020, Ireland shut down for the first time with COVID, supposedly for 4 to 6 weeks, which turned out to be over 2 years. That changed operations. So all these, any company involved in chemical safety should have gone back and started again, because they're holding chemicals being used, storing chemicals, all of that should have been reviewed. I'm not a gambling person, but I would, if I was, I'd have put good odds that there's a lot of companies didn't bother. They just considered the fact the building is locked, the chemicals are locked in, they're safe. And for some, they were. But for others, maybe not, from a safety perspective. Storing things, just leaving them static, standing, may not be the best thing for some of them. Like a good wine, you need to constantly rotate the bottles. So basically what we start, just running through these very quickly, you examine the processes, all the steps in the process, what exposure could occur, who, what, where, when, and how, all the questions we have to ask in terms of where could this exposure occur, or what accident could occur, or could an accident happen? Could something go wrong? There's an example given here. Precipitation of gold from cyanide solution, junior researchers in the laboratory, only minimal training and not accustomed to the PPE. Twice a week, zinc powder is added to 100 milliliters of aqueous 0.10 m solution, cyanide solution, or sodium cyanide solution, contain dissolved gold. The gold particulates are precipitates and it's collected by filtration. Work performed on a crowded open bench top alongside work on other project and involves preparing numerous HCl or HCI solutions. It's a standard process. Lots of people working together, process going on. It's just part of the process, but you're using dangerous chemicals. Guys aren't used to the PPE. PPE takes getting used to. Ask anybody who tried to get used to wearing face masks over the last 3 years. A lot of people refuse to wear them. And the most common complaint I heard was, can't get used to these damn things. Especially if they wore glasses. I found that myself when I started to use the masks. My glasses fogged up. So that becomes frustrating until you learn how to use them, until you learn the trick of how to work it. And then once you learn the trick, you're okay. But there's a learning curve with these things. Sometimes we get fed up with the learning curve and just cut corners. We identified the solution. We identified the hazard. And again, we're using the same example. Acute toxins can be harmful. Harmful exposure can occur through ingestion, absorption. It's amazing, actually. When I used to teach first aid, one of the things people keep forgetting about was how do you ingest poison? And most people thinking ingesting poison as injection or inhaling or swallowing. And it's amazing how many people don't think of you ingest poison through absorption. Absorbing it through the skin. Like a big sponge. And you see it every year. There are people, gardeners, turn up at A&E or turn up to their doctors with chemical burns and chemical issues because they're spraying their garden with chemicals to kill weeds or to kill bugs or to whatever. And there's a bit of a breeze. It's a summer's day, so they're out in t-shirts and shorts, and it's a light piece of the spray blowing back on them, and all of a sudden they're having blisters and reactions to it on their skin. And they go to a doctor, or they collapse if they get a strong enough exposure. They go to a doctor, and the doctor's basically, what were you doing? I was only out in the garden spraying. I must be after getting stung by something. You didn't. It's the spray. So harmful exposure, we need to be aware of the fact that, we can inhale products. And when gases are mixed, when products get mixed, they create gas. When I was growing up, my father used to restore antiques. My mother used to make fishing tackle. The smell I grew up most with was the smell of polyurethane in the house, because my mother used a varnish on the fishing tackle, which was polyurethane based, or had polyurethane in it. And my father used to use Evo-Stik as a glue. And I mean, there was a period of time when one of the most popular drugs in the world was glue sniffing. And the glue they sniffed was Evo-Stik because of the chemicals in it. No wonder I ended up weird, because this was the what was in our house. Was back in the day, it wasn't realized it was that dangerous. Allegedly, yeah. Unfortunately, I've also, through the first aid side of the business, I've come across people who have actually been involved with some of these things on the other side of the fence. It's sometimes we don't think about them. Sometimes we're rushing. Sometimes management doesn't see it. Sometimes you're working in operation in an older building that doesn't have the same ventilation as a newer building would have. Because we're working, that's just our business. Our business has expanded. We're now bursting at the seams. We're on top of each other in terms of work, where we're working, and you've got dangerous systems happening next to each other, but we just don't have anywhere else to put them. We've got chemicals being mixed next to chemicals being used, and we don't actually have space to put them anywhere else. And it was just a logical place to put them, because then in our heads, all the chemicals are in the one place, so we're keeping it safe from everywhere else. Theories, yes, but you need the ventilation to support it, or the filtration systems to support it. We can partially do it. Characterizing the safety risks. What are the factors affecting the likelihood of exposure? And what type of level do we see that exposure at? Low, medium, or high? What factors affect the consequences of the exposure? Will they be low, medium, or high? Again, all common sense stuff. We can map them out as to where we think they are. On the basis of likelihood and consequence, where are they? The exposure to this gas, is it low, moderate, or high? And why is it like that? There's another one of our whys, right? Why is it that high? Why are we putting it there on the map? Then we ask the hard questions. Would we feel safe if we were doing the work? Would you, as a manager, feel safe to stand at that location and do the job? If you say no, well, why? So you want somebody else to do it, but you're not happy to do it. So why not? If it's would you be happy to work up on top of that scaffolding that's been set up there? Well, no. Why not? Because it's not secured, or it's not this, or it's not that. Well, then why are you expecting other people to do it? It's a very strong question. Would you do it? Would you, as a manager, as a HSA person, as an auditor, would you work up there? It's a great way of making a decision about this, and driving home, should this be an acceptable risk or not? Would I work in that environment? No, I wouldn't. Well, if you won't do it, and you're the expert in the safety side of things, then how would you expect somebody else to do it? The answer then is the risk acceptable? The answer is no, it's not acceptable. Are current controls and practices at acceptable levels? And again, why or why not? Are there standards that need to be, in this case in chemicals, in relation to cyanide, that need to be adhered to? And are there any other limits? And that's one where you need to start asking, well, do I know all the information? Maybe I don't. Maybe I need to ask for more information. Maybe there's wider ramifications I need to be aware of. Because if I need to have as much information as I can in making the decision. Maybe I don't think it's acceptable, but there is something I'm missing. There's something that actually makes it acceptable. There's a process or a procedure that negates the danger. The second last one we look at here this evening is, we implement the controls. Whatever we need to do under substitution, engineering, administrative, and PPE. Whatever we need to do to make it work, whatever steps we need to put in place, we need to make it happen. It needs to become part of the new SOP, which everybody must, one, sign up to, and everybody, two, must fully implement. No shortcuts, no wiggle room, no finding an alternative, no messing around, no management overriding the decisions. Everybody must be impacted by it. I can still remember walking into a production department in the factory. We didn't have the dangerous chemicals situation. What we did have was noise. Everybody was supposed to wear earplugs. I was actually on the factory floor when I realized I'd forgotten the earplugs, and I decided I was only going to ask a question. Ran into a department, and I wasn't even staying in the department. I was going from the door of the department to the office, to the production manager's office, which was on the other side of the room. So I was literally running across the room into an office to close the door. I got halfway across the floor, and I got stopped. I got stopped by somebody who pointed to his ears. I had no ear defenders on. He had these earplugs, and he was pointing, and I put my hand up to my ear, and of course I'd forgotten them. And he put his hand in his pocket. He could have sent me back to my office to get them, but he put his hand in his pocket, and he had a packet in his pocket, and he handed me the packet to put them on. It's that type of everybody. I was considered management, so everybody, didn't matter who I was. I walked in there, an area where ear defenders is a requirement. I ran in, no ear defenders, even though I'm only going across the room. Nope, you put on ear defenders or you leave. If I'd refused the ear defenders off him, he would have been well within his rights to turn me around and send me out. And if I refused, he could have escalated it. He was a team leader. He could have escalated it to a supervisor, to a manager, to general manager, all the way up the ranks, and I wouldn't have had a leg to stand on. I was in breach of the controls. End of story. You're out the door. You're out of the department, basically. So it's important that once a procedure is put in place, it's implemented, and it's implemented in its totality. Maybe we can substitute something, a less hazardous mix. That's one way of looking at it. We can change the process. We can put engineering controls in place, so like different barriers for ventilation, dilution, or whatever, local exhausts. We can put things in that will actually help protect the reaction, protect the exposure. Like these machines where you have you enclose the hazard in this box, and you can use these gloves to handle it remotely. We can put rules in place in relation to the safety procedures we put in place, how we organize it, the SOPs we've talked about. We train people to the SOPs, but they still have to be policed. Just doing them and writing them and say that's it, we have them done, pat ourselves on the back, let's go for coffee, that doesn't sort the problem. for most, or for not most, for a lot of people, putting them through an SOP training is we have another training day to go through, as if we don't have enough to worry about. They do it because they have to do it, and then they'll sign the paper because they have to do it, and then they go back tomorrow to doing what they used to do anyway. I'm going to park it there because it's 9:30 and we're over halfway through this anyway. I'll park it here and we'll pick it up next week. I will run through these. We'll finish these next week. And I shall talk to you all. Have a good bank holiday weekend if you're doing anything for it. If not, I hope you get the time off and get to relax. Have a good week. Talk to you soon.